Hi guys, so here's my video on waves. So last week you need to do a web quest that looked at the difference between transverse waves and longitudinal waves. I did post an answer key, so make sure you're checking your answers and not just like looking at the answer key. Make sure you're doing your work. Okay, so a transverse wave will move up and down. So that's a transverse wave. It has parts. The parts of the transverse wave are known as crest. So the crest is the highest part. Trough is known as the lowest part. There is a midline. The midline is what I am going to outline for you right here. This is the midline. I don't know why it's in yellow. Let's get a nice color here. Here is your midline. Okay, so if you go from the midline to the top or the midline to the bottom, that is known as your amplitude. That measures how high the wave goes. Wavelength is measured from crest to crest. So this would be the wavelength, or trough to trough. It doesn't matter. As long as you're going from one consecutive crest right here to the next and one consecutive trough to the next. All right, so moving on to our next thing. Okay, so let's now get to the pointer. Okay, so here is an example of a transverse wave. Notice you're moving the wave up and down motion. Don't forget, a transverse wave needs a medium to travel, so a solid, liquid, or gas. Okay, so examples of a transverse wave. You have I can't think of the word, but at a sporting event, that's what I was looking for. The wave, you start the wave. Strumming the guitar, you can make the waves on the actual guitar. Ripples on a wave. There was an example that I showed during our Google Meets of that. So a longitudinal wave will take the medium that it's traveling through and actually compress it. And it travels long ways. That's why it's called longitudinal. So it will compress the medium, move, compress the medium, move. This is a much slower way of moving. That's why your longitudinal waves are slower. So light wave is transversal and longitudinal is sound. That's why light travels faster than sound. Okay, so a compression will take the particles and move them together. A rarefaction spreads them apart. And your wavelength you will measure for a longitudinal wave from compression to compression, and that is your wavelength right there. Okay, so instead of moving your slinky up and down, if you have a slinky, you can send burst compressions, but make sure it's horizontally, or you compress it yourself. So some examples, sound wave, like I said, sound is a huge compressional wave or longitudinal waves. Okay, so another part of your lesson this week and last week was looking at wavelengths. A long wavelength is a longer distance from crest to crest, where this one has a shorter wavelength, shorter distance from crest to crest. Okay, now you're going to learn the word frequency. Wave frequency means how frequent the wave happens. The number of wavelengths that pass at a given point is actually known as its definition, vibrations per second, and it's measured in hertz. So how frequent the wave is depends on its wavelength. The shorter the wavelength, the more frequent it will happen. The longer the wavelength, the less frequent it will happen. So as frequency goes up, wavelength goes down, and as frequency goes down, your wavelength stretches out. And that's it. I will be at my Google Meet at Thursday, 10:15. Hope to see you there. We will be introducing another part of waves. And that is it.